Or welcome to our college algebra. Today I will teach you matrix theory. I will talk about the matrix theory. My class, I will divide by two main topics. First one is basic properties of matrix, and then the next section. I will make some operation, the product of the matrices. Actually, I want to show you where the properties of the matrix, and then how add and subtract matrix, and then also how the product of matrix. Okay. All right. First of all, we have to define what I mean the matrix, or how classify the matrix. It says we classify the matrix by dimension. Okay. Number one dimension or order. All right. Also, number two is we by number of rows and columns. Okay, this is the way that we classify the matrix. Okay, let me show you some examples. For instance, if we have like this matrix 2, 7, 5, and 4, 6, 9. This matrix has two rows. This has two rows and three columns. Right? That this matrix. Let's talk about for example, the matrix. The matrix. Let me write 6, 5, 3, 4, 5, -1. This one matrix is of order of 3 by 2. Okay, this is a 3 by 2. Let me write another example here. Let's write 5, 8, 9, and then 0, 5, -3, and then -4, 0, 5. This is another example of the matrix. It is of order of 3 by 3. 3 by 3, right? 3 by 3. Let me write another example. This is the matrix, another one matrix of 1, 0, 5, -2, and then 5. This is another matrix. This is of order of 1 by 5. 1, 2, 3, 5. 1 by 5. See? 1 by 5. All right. Let's write okay, I think this is enough examples. Let me write this one, this letter, and write another one in this way. Let me write this 3, -9, and 0 and 2. So this matrix is order of, this is order of 1, 2, 3, 4 by 1. See, this is the way we call in during my class the matrix. Okay, so we have operation with matrix. Okay, this is some properties, sometimes the rule that we must know. Okay, but let's talk about then about in general. So in general, the matrix, the first, the easy operation. Let's talk about the sum. Okay, the sum of two matrices. Two matrices. For instance, A and B. So we need to know some rule. A and B of the same order is a matrix A plus B, right? And this, so this is the main idea is let me only matrix of the same order can be added. What I mean this, I explained it before. What I mean the order, all right? The matrix. So only the same order. This is very important. This is, I think, the main idea of when we added also multiply matrix. So don't forget this idea, okay? I will erase it. Only matrix with the same order is allowed. We are able to add it or practice add or subtract. That's the same thing, add or subtract. So example, let's write a problem. Find each of the following sum. So I will give it to you couple of problems. All right, couple of problems. First problem. Let's write. Let me write 5 minus 6, 8, 9. We have to add this matrix with negative 4, and then 6, 8, and negative 3. We have this matrix. So how added? We have this example like this. We have to start it with this 5 times negative 4, right here, and then also we have a 5 times 6 6, no, not times, we added, so 5 plus negative 4, right? Because we added, so negative 6, so this one, take the negative one, 6 plus 6, and then next one we will have 8 plus 8, okay, 8 plus 8, and then the other, this the second one, 9 plus negative 3, right? This is equals, you got it. The matrix here, the first one, you got it. We will have 1 here. We have a 0 right here, and then in here is 18, and then 9 minus 3 is 6. This is the answer, right? The solution of the first one. Let me write another one, another problem. Let's add it to this matrix, 5 and 8. Add it with negative 6, 3, and 12. So we have this very easy, right? The first one is actually it's immediately, it's straight right here. We will have negative 4, we have 8, and then we have 12 plus 20, 12 plus 8 is 20. That's the answer. For instance, let me give you this example. If we have this matrix, for instance, 5, 8, and then 6, 2, added with 3, 9, 1, and then 4, 2, and 5. What happened here? So this matrix is not the same order, so are different orders. Different orders. So therefore, the sum this matrix, let's call A and B, assume A plus B, does not exist. Yeah, remember the concept that I explained, I talked with you at the beginning of my class. So must to be the same order. In this case, this example or problem C, these matrices are not the same order, so different order, right? That's why is the sum that is not no sum. All right, let me continue with the subtraction. Another examples of subtraction. Let's talk about the subtraction. Subtraction. So subtraction on matrix. So if A and B are two matrices, then in order, of course, A minus B is equals A plus minus B, right? So example. One example. Talk about one example. I think this is fine. We done one example. So let's talk about negative 5, 6, and 2 and 4. This matrix. Subtract this from this. Negative 3 and 2 and 5 and negative 8. Right? So remember, when you added numbers, there is the same thing. Just this first one, moving here at the same equals 2 and 4. So we have to change all these. Remember, subtract a number, it is the same to add the symmetric number. So the symmetric numbers of this matrix, you have to write the symmetric number because subtract everything. So now everything in size will be changed of signs. Changes its signs. So here is going to be first one. Should be if we subtract, we have let's write down 5 at the beginning. This is negative 3. We will have a positive 3, and this is going to be negative 2. It's going to be negative 5 and positive 8, right? All numbers inside the matrix change its sign. So now you are able to add it. So the first one is going to be in conclusion. I don't want to do the whole process, but the first one is going to be negative 2, and then 4, and then negative 3, and then 12. This is the answer or our matrix. Why? When you multiply this by this, for instance, you subtract negative 5 plus 3 is negative 3. I mean, negative 2. And then this one, next one, negative, so negative 7, negative 3. Yeah, it's negative 2. All right. this is the conclusion. I don't want to do the whole process. Remember that I did before, but you practice, do the process. That's the answer. So now I don't want to stay here with a longer because it's simple, it's easy right here. Let me show you the product, matrix product. Okay, matrix product. So example, find the product. Problem one. Let me show you one example. Find the product. Find the product AB, where let me write here A is equals and this matrix 2, 4, and then 5, 6. Now we have to multiply and B. Matrix B. Remember, it must be the same order. Same order. -3 and 5, and then 4 and -2. So step one, I will solve a problem step by step. Step one. Okay. Multiply elements of the first row. This is the first row of 8. This is 8. And the corresponding elements of the first column of B. All right. So then we have two. Let me do it right here. AB equals 2, 4, 5, 6, multiply by 3, 5, and 4, -5. Okay. So follow the direction. 2 times -3 here. 2 times -3. All right. 2 times -3 plus the second one, 4 times 4. So this is equals -6 plus 16. 16, so the answer is 10. So therefore 10 here, 10 is the first row, first column of the product matrix AB. Okay, so step two. Multiply the elements of the first row, of 8, and the second column of the second column for entry of the product matrix. So the first one was 2 times 3 right here. 2 times 4. I mean 4 times 4. 2 times 3, 4 times 4. Right? Right there. So now maybe I was thinking and use a different color, but let me write right here. AB. So equals let's multiply here. This is step number 2. 2, 4, and then let me use different colors here because maybe we get confused. So this is step number 2. Step 2. Let's write A, B. It is the same. So write 2, 4, 5, 6, -3, 5, 4, and -2. So now use the second column. So we have to multiply 2 first column, but the second column. So right here is 2 times 5, right? Plus 4 times 4 times it's negative, all right? Negative 2. 4 times negative 2. That will be equals 10 plus negative 8 is equals 2. All right, that's it. That's step 2. Step 3. Step 3. So AB, so again 2, 4, 5, 6. So look at this, how I'm multiplying negative 3, 5, 4, and negative 2, right? So this is it's 2. Yeah, it's negative 2 here, no negative 5. It's negative 2. It's negative 2. Okay, sorry, it's negative 2. Okay, so now we have to multiply. Now starting with this number, the bottom 5. So we have to multiply 5 times negative 3 plus 6. Now 6 times 4. Times 4. This 4. 6 times 4. So this is equals 15. Yeah, 5 times 3 is 15. Negative 15. Negative 15. Negative 15 plus 24. 6 times 4 is 24. So this is equals 9. All right. So the second row, first column entry and the product matrix is 9. Right there. Okay. So step 4. Let me go to the step 4. I will erase everything here. Let's go to the step 4. Let's use this color. Step 4. Almost done. So step 4. So A times B is equals 2, 4, and then 5, 6. Negative 3, 5, and then 4, negative 2. All right. So now multiply this. This is going to be 5. Let's go to the second one. So 5 times 5. Okay. Plus 6 times negative 2. How much is it? 25 minus 12 equals 30. Right there. That's it. That's is the second row. This is the second row right now. Is the second row. Second column entry. Second row, second column entry. All right. So step 5. Step 5. Step number 5. Write the product here. How write the product? So we have our conclusion here. A, B equals 2, 4, 5, 6 times negative 3, 5, 4, negative 2. All right. This is equals. Remember the number, but we got it. We got it. The first one, remember 10. The second one was 2, and then 9, and this one is 13. So this is our answer. All right, you check the video. You don't remember the step 3, step 2, step 1, just check my video and then check all the steps for household the product on matrix. Okay, let me show another example without all the steps. So I did all the steps. So now I will skip the step in this next problem, next product matrix. So it's the same rule from the same. Two matrices can be multiplied only if the number or the columns of A and B are the same as the number of the rows in the B. All right, it's the same rule. So let's solve another example. Find A B here and B A if A is equals let me write the matrix here 1 7 and then -2 and 2 and B equals let's write 10 -2 2 and then 3 4 and -1. Thus let's let me this is 3. Let's write 10 I mean 1 I different way. Let me write 1 0 4 this -2 and 2 and then let's write 3 1 4 and -1. That's the second matrix. So AB equals 1 7 -2 2. Let's just, I want to confuse another marker right here. So AB equals this matrix 1 7 -2 2 times 1 0 -2 2 and then 3 1 4 -2 -1. All right, so this will be equals we try to simplify. All right, we try to simplify my problems. All right, let's start with this one. So first is 1 times 1, right? 1 times 1, then plus what else? 7 here no, this is 3 here 1 2 3 4. All right, 1 2 3 4 1 times 3 and then 3 times 1 and then yeah, let me write right here and 7 times here 7. Let me do everything 7 here times 1 and then plus 2 times here 2 times 3 so here the next 1 times 1 and then 2 times 3 plus negative 2 times 3. Yeah, negative times 2, 3. Here, now 1 times 0, 1 times 0, and then plus negative so in the barrel right here. Oh, let me finish in the top. Negative 3 times times 1 plus 1 times negative 1 plus negative 3 times 4, and then 1 times 2 plus negative 3 times negative 1. Negative 1. All right. So in the bottom, we are here 7. Here 7 times 0 plus 2 times 1. 2 times 1. Now 7 times negative 1 plus 2 times 4. Times 4 plus 7 times 2 plus 2 times negative 1. It's right there. I think it is 2, 1, and then negative 2 times 3, negative, yeah. So the answer here is you added you are able to do it step by step, but it's too long, too much space. So I will write the conclusion right here is negative 8. Here minus 3, and then negative 13 and 5 on the first line, and second is 13, 12, 1, and 2 and 12. That's the answer. Yeah, it's fine. So now let me go to another topic. This is a product of matrices, something like this. So you must follow. It's long. The process is very long. Sometimes that's why I get worried sometimes. But it's important. I would like to explain it all the step, all process. So this is I did in the first problem, the process. Okay. Let me talk about multiply inverse or multiplicative inverse of a 2 by 2 matrix. So let's we have some property here. The property we have the identity. So when we have a inverse equals a, and inverse a, this must be equals a. All right, both. It is the same. This is some property. Compare this product statement of the identity property. This is identity property. Okay, identity property. So in other words, if we have like a times 1 is equals 8, and also if we write 1 equals a is equals 8, also it is the same thing, right? For any real numbers a here, for any numbers A 2 by 2. Identity matrix. Matrix. Okay, and then it's like this. Identity is equals 1 0 0 1. When you multiply by that, you get the identity matrix. Let's solve some problems using the identity matrix. Okay. How solve the problem, the identity matrix? Let's write one example. So if we have m equals this matrix, -2, 6, and then 3 and 5, this matrix, verify, we have to verify, verify. So verify that mi is equals m, and im equals m. We have to verify this. So then we have here mi right here equals just write the matrix 2, 6, and 3 and 5. So multiply by this identity property. So let's go. It's another example of multiplication. So right now, first one, 2 multiplied by 1 here. 2, we have to multiply -2 by 1. -2 by 1 plus 6 times 0. Right? And the bottom, 3. Next one, 3 times top, 1 plus 3 times 5. 0, not 5. 3 times 0. Okay, here. Go the next one. We have 2 here times 0. -2 times 0. And then plus 6 is 6 times 1. 6 times 0, and then 6 times 1 plus 6 times 1. Okay, and the bottom we have 3. We have 3 times 1 right here. 3 times 1 plus this 5 plus 5 times 1. All right, 1. That's the matrix. So this is equals, let me write, and no, I don't want to do another page, another page. So this is equals, here, how much is this? -2 plus 6. You have plus 6 is 4, right? So this is -2. No, here, -2, 6, and then the other one is in the other way. Right here we have -2. So it's equals. It is the same one. So we have 0 here. So this is -2, right? And then here is 0. So this is 6, right? Here 3, and this is 0. So it's 5. 5 right here. 3 and 5. Right there. That's the answer. Okay, so this is equals m, right? So also let's okay, you see? So now the other way. Let me, because this is the first one. To verify m, and then also mi equals m, and then the other one im equals m. That's the other way. So so also that's the other way, the last one. So im equals, let's write 0, 0, 1 times negative 2, 6, 3, 5, right? Multiply, so this is equals, will be equals here. 1 times negative 2 plus 0, 0 times 3. Okay, and the value we have 0 times negative 2 plus 1 times 3. Okay, next one, 1 times 6 plus 0 times 5. And the value 0 times 6 plus 1 times 5. See? So this is equals, it's the same. See? The first one, we will have 2, negative 2, 6, 3, and 5. Right? It is the same. So we prove the basic property of the matrix in algebra. So, but we have that property. So let's solve another problem. Let me show another one problem. One more here. So we have k equals negative 2, 4, 0, and then 3, 4, 9, then 0, 8, and negative 6. We have this matrix here. So we have to find the 3 by 3 identity matrix. So identity matrix, and show that identity is equals k. All right. So we have the 3 by 3 identity matrix. Matrix is right here. Let's write the identity. This matrix I equals 1, 0, 0, and then 0, 1, 0, and then this is 0, 0, 1. This is the identity, the 3 by 3 identity matrix. Okay, by definition, so our matrix multiplication we have, remember, we right now we know what are the properties of the matrix. Also, we learning how add and subtract matrix, and also how multiply matrix. Okay, we have this problem here. K identity equals this matrix, negative 2, 4, 0, 3, 4, 9, 0, 8, negative 6. Okay, so now the identity matrix times 1, 0, 0, then 0, 1, 0, and then 0, 0, 1. This is a 3 by 3 identity matrix. So this is equals, when you multiply, you don't want to do the whole process. You right now, you know how multiply matrix, okay? So I show you. What is the process? So now we have here negative 2 has to be equals, and this one, 3, 4, 9, and then 0, 8, and -6. Okay, this matrix is equals K. So that was our question. See? So we learning how the properties of the matrix. Also, we learning how add and subtract matrix. Also, we see some problems. We study some problems how multiply the product matrix, and also we know what is the identity matrix. The identity matrix, like this, for instance, is 3 by 3 identity matrix. We saw we learning how what is the 2 by 2 identity matrix. The problem before to this one. So that's it for today. Thank you so